Good evening. In this video, I will be explaining the code that I implemented on an ARM Cortex microcontroller, which is situated on this Texas Instruments Tiva C series launchpad. And the following was what was implemented. So a default code was provided for the lab that we performed on this, and we had to make certain changes to the code, to the C code. So we had to ensure that the right button, when pressed, causes the red LED to flash at 2 Hz. When the left button is pressed, it causes a green LED to flash at 1 Hz. And when both buttons are pressed, it causes the white LED to flash at 5 Hz. So the following was what I performed on the code. I commented out the original conditional statements because there were previous conditions at which the LED should flash. So I commented those out and instituted my own versions, having the conditions based on the button states, which were already defined. Afterwards, I put in the LED command equals to red LED, and then I instituted the delays. So, as of this button states, when true, it causes, that is when true, that's when the buttons are pressed, it would cause the specific color for those specific button states to flash. So, at button state R, when we press the right button, it causes the red LED to flash at the specified 2 Hz. And if you notice the calculation, when calculating frequency, you make it, when calculating the period or the delay, you take the inverse of the frequency. But because this max delay has been defined at 2 different points in time in the program, you have to divide the original value of the delay you have by 2. Therefore, for 2 Hz, you would expect about 500 milliseconds of delay. But instead of that, you divide that by 2, I have 250 milliseconds. Therefore, when I press this button, you can see that the red LED is flashing. Now, if we connect the pins, of which, if we connect these pins here, one specifying the red LED, and which is at PF1, and we connect this ground section, the black cable section to the return actually, and we press this, it's flashing at red, it's flashing the red LED at 2 Hz, and as you can see here, we have the 2 Hz frequency confirmed on this oscilloscope. Now, the next statement, we have an else if statement for when we press the L, and we'll move this here, the red section of this probe to PF3, which specifies the green LED output in terms of the electrical signal it will send through the probe to the oscilloscope. And then when we press the left button, you can see it's flashing, and it is to flash at 1 Hz. And if you see here, we have 999.2 millihertz, which is approximately 1 Hz. Now, if both, that is both R and L, both states, both buttons are pressed, we should have the white LED flashing as well. Remember that we took the inverse of the frequency provided and divided it by 2, since we have the max delays stated twice in this program. So you can put the red section of this probe on any of the LEDs constituted in producing the white LED. So I'll put this back on the red section on PF1, which is connected to the red LED, and then we'll press both buttons, and you'll see that as we do so, we have the oscilloscope generating 5 Hz. And that was it. So that was a relatively simple implementation, and just changing of certain aspects of the C code on this to obtain the required functionalities that we expected from the ARM Cortex microcontroller on the Tiva C series Texas Instruments launch pad. So thank you so much for watching.